Good morning, dear students. Welcome back to the channel. Today we are having one more new video. This is the lecture number 8 for thermodynamics. This is lecture 08 for the thermodynamics. Till the last video we have covered the uh, questions of first law of thermodynamics. Now we are going to discuss about the enthalpy. What is enthalpy, children? Enthalpy means heat content of system. I think this enthalpy will take 2 lectures. Heat content of system at constant pressure. Okay, here what I said, it's a heat content. Enthalpy is what? Heat content. It is a heat content of system at what? At constant pressure. The formula you know, familiar, you are very familiar. Delta H is equal to delta E, or you can say delta U. Both are the same thing, change in internal energy, delta E or delta U. So delta H is equal to delta E Ng RT. That is the formula. Okay, but we are not going to use this formula. Okay, so enthalpy, it is represented by H. Okay, so what is the definition? Formula, mathematical representation. H is equal to U plus P into V. H is equal to U plus PV. U is what, children? U is internal energy. P is pressure external, and V is volume. Okay. So on that basis, see what I said, it is a heat content. Suppose this is the vacant space. This space is vacant. This space is vacant. Okay, it's a vacant space, and here I want to put one system filled with gas. Here one system you want to place. Here gas is filled at the pressure P, and volume V. P pressure, V volume. So what you can say about the heat content? So from here, heat content is equal to what? Internal energy. If you remember, we have calculated internal energy for what, children? For molecule. At the time of internal energy, I told you internal energy for molecule or atom. Okay. Then plus to establish system at pressure P and volume V from empty space. Okay, to establish system at pressure P. Now what is pressure P? What is pressure P and volume V? So suppose this is the empty space, children, and you want to place this system in this empty space, then we need pressure V and volume, pressure P and volume V to establish this system. To establish system at pressure P and volume V from empty space. So you have to do something for that. You have to create that pressure, that volume. So the sum of internal energy and that second part to establish system at pressure P and volume V from empty space. That is our heat content of the system. Okay, that is the heat content of the system. If we are talking about the unit, so it is represented in joule, joule per mole. Okay, so this H is not significant for us. H is not significance. S is not significant for us. Then what is significant? What we can calculate? Exact value of H calculation is not possible. So what we can calculate? We can calculate delta H. We can calculate delta H. What it is? Change in enthalpy. See why I am saying this, children, because anyhow you calculate the internal energy, okay, but how to know this pressure and volume, how to put the system in empty space? Then what you have to do, that is a microscopic observation, microscopic calculation. So that cannot calculate it normally. So we cannot calculate exact value of H. Then what we can calculate? We can calculate change in enthalpy, delta H. Okay, so once again you can write delta H is equal to now delta U plus delta PV. Delta H is equal to delta U plus delta PV. PV is what, children? At constant, we are talking about constant pressure. Okay, so constant pressure PV is what? You know that P1 V1 is equal to P2 V2. So what you can write? PV are the variable here. You can write delta H is equal to delta U plus, at the place of delta PV, what you can write? You can write P2 P1 minus P1 P2 P2 V2 P2 V2 minus P1 V1. That is the formula which we will use in that case. Okay. Okay, so delta H is equal to delta U plus P2 V2 minus P1 V1. That formula we will use here. You know that P and V both are variable. Okay, in that case, children, here two conditions are there. Okay, so this I want to erase actually. So check it here. I am writing here. We are having two conditions for this. Constant volume, delta H at constant volume and delta H at constant pressure. So one thing, children, you know that 90% of the chemical reaction completed on constant pressure. Okay, constant pressure. So here formula will be delta H is equal to delta U, pressure is constant, then it's come out delta V. And at the same time here delta H is equal to delta U plus, here V is constant, then delta P. That formula we have to use at constant pressure and constant volume. So this formula is valid, 100% correct, 100% correct for any process. Okay, for any process, children. Okay, further we will check some problem. Check it once. Question number 1. Question number 1 is, an non-ideal gas a non-ideal gas goes from state 1 to state 2. State 1, 2 atm pressure, 3 liter volume, 95 Kelvin temperature. State 2, 4 atm pressure, 5 liter volume and 245 Kelvin temperature. So they are saying find delta H if delta E is equal to 300 atm liter. So how can we calculate it? So delta H is equal to delta U plus delta PV. So delta H is equal to delta U plus what you can write P2 V2 minus P1 V1, delta U, that is you can say delta E also, that is 300 plus P2. P2 is what? Check it here. P2 4 and 5. 5 for the 20. So it is 20 minus P1 2 3 3 2 just 6. So it is 300 plus 14. So it will be 314 atm liter. That will be your answer. Question number 2. An ideal gas expand isothermally from 1 liter to 10 liter at 25 degrees Celsius. Find the value of enthalpy change delta H. 4 options are given: minus 7 kilojoule, plus 7 kilojoule, minus 44 by 3 kilojoule, and D is 0. So see children, here the point is isothermally means it is given isothermally. So isothermally means what? Temperature constant. Here T is equal to constant. If T is equal to constant, then Boyle's law, P1 V1 is equal to what? P2 V2. At the constant temperature, Boyle's law is applied. Then delta H is equal to delta U plus delta PV. And for isothermal process, and this is what? Ideal gas. So for ideal gas, delta U is what? 0. I already told you. And here it will be P2 V2 minus P1 V1, and both are equal. Then what is the answer? 0. For ideal gas, change in enthalpy value will be 0 because it depends upon the temperature that I told you many times. Let's talk about enthalpy once again. So few points related to enthalpy. So first point, H is what? H is state function. It is a state function. State function means, children, state function means change depends upon final and initial state. Change depends initial state and final state. So not affected by path, not affected by path followed. That means delta H is equal to H final minus H initial. Second property, delta H cyclic, delta H cyclic process, that is 0, because suppose like that it is, if you are saying from A and return back on A, so it is not depends upon the path, it is depends upon the final and initial. So final and initial condition same, then in the cyclic process its value is 0. And H is extensive property. What is H? It's a extensive property. Okay, so these are the things. Once again come to the formula, children. What formula we discussed? We discussed that at constant pressure till H is equal to U plus PV, delta H is equal to delta U plus delta PV at constant pressure, delta H is equal to delta U plus P delta V. So from here we can say one more thing, delta H is equal to delta QP. How, sir? I will tell you how, children. You know the first law? From the first law, delta U is equal to delta Q plus delta W. Constant pressure, pressure is constant, then delta U is equal to delta QP minus pressure external PV. So from here delta QP is equal to delta U plus P delta V. So this is equation number 2 and this is equation number 1. So from the equation number 1 and 2, right side are equal, then left side also will be equal. That's why this relation is true. Got it? Same time, delta H is equal to QP. This relation we proved. Yes or no? Yes, sir. Now, what is Q, children? Q is equal to NC delta T. That is the formula for heat. N is what? Number of moles. C is what? C is molar specific heat capacity. Delta T is what? Change in temperature. Okay, so what is QP? Heat at constant pressure. That will be NCP delta T. What is NCP delta T? CP is what? Molar specific heat capacity at constant pressure. For a small function, how to find delta H? So here what you can say, children? QP is equal to delta H. So at this place what you can write? At this place what you can write? Delta H. So delta H is equal to, you can say, NCP delta T. NCP delta T. For a small function, dH is equal to NCP dt. Okay, so this relation is important, children, for delta H, that you have to remember. So again, question practice. One question, two question we solved. Then question number 3. 2 mole of helium is heated at constant pressure from 0 degrees Celsius to 50 degrees Celsius. Find delta H in joule. So children, what? Delta H is equal to NCP delta T. Mole is given to CP. CP how to find? Here I am solving. Helium is monoatomic. Then CP is equal to, so first CP you have to find. Cv is equal to monoatomic 3 by 2 in the calorie. In the joule it will be 2 and joule 8.314. So 8.314 and so Cp is equal to, or direct formula you can apply. Wait, Cp is equal to F by 2 plus 1 into R. So F by 2 means 3 by 2. So 3 plus 2, 5 by 2. Okay, so here it will be 5 by 2 into R into temperature difference is 50. Either in Kelvin and Celsius change will be same. So it is 2 into 5 by 2 into 8.314 into 50. So you have to calculate 2 cancel. It will be in Kelvin and this R value in joule Kelvin, joule mole Kelvin. So mole from here it will be cancelled, Kelvin here it will be cancelled. So it will be 8.314 into 5 5 is 25, 250. So whatever the answer you can calculate. That is the use of this formula. For Cp, this formula you have to use. R value you have to remember 8.314 joule per mole Kelvin. That is the value of R. Okay. So these are the small questions. Now suppose a relation between delta H and delta U in chemical reactions gaseous state. Okay, so that relation we will check. Relation between what I said once again, relation between delta H and U for a chemical reaction in gaseous state. So any reaction, reactant to product. So for this, delta H is equal to what? Delta U plus delta PV. Okay, so delta H is equal to delta U. PV is equal to what, children? nRT. So at the place of PV, what you can use? nRT. Delta nRT. So delta H is equal to delta U plus R and T are constant. Then delta Ng. Ng means gaseous state. RT. That formula in the beginning I told you this formula. Okay, this formula where you will apply constant pressure, constant volume. This formula all the time it is correct, and this formula at constant pressure and constant volume you can apply. Delta U means delta E also somewhere you got. Delta Ng means what? R means what? Gas constant. T means what? Temperature. So delta Ng is what? Moles of reactant minus moles of moles of product, moles of reactant in gaseous phase. Okay, so here pressure constant, what I am saying here, pressure constant and temperature constant. So according to this, pressure constant, temperature constant, R is already constant, then temperature depends upon volume. Volume increases, temperature increases, volume decreases, temperature decreases. So suppose one reaction is given, find out the relation between delta H and U for the following reaction. Question is N2 gas plus 3H2 gas and 2NH3 gas. So what is the relation? So delta H is equal to delta U plus delta Ng RT. Calculate it. Delta H is equal to delta U. So delta Ng is what? Np minus Nr. So product how many moles? 2, reactant 4. So it is minus 2. So delta U minus 2RT. That means delta H is equal to internal energy change, and here you have to subtract something in the internal energy, then delta H is equal to delta U. So which one is greater value? Delta H is greater. So what you can say? Sorry. delta u will be greater. So here the relation is delta u is greater than delta h. You are getting my point here. Once again I am saying here delta h is equal to u minus RT. So you have to subtract something in the delta u value, then it is equal to delta h. So which one will be bigger? Delta u. Okay. Second question, H2 plus Br2, it will be 2HBr gas, all in gaseous state. So delta Ng is equal to what? Here 2, here also 2. 2 minus 2, it is 0. So delta H is equal to delta U. Number 3, MgCO3 solid, MgO solid plus CO2 gas, delta Ng reactant product, only one gas is there, reactant no gas is there, then delta Ng is equal to 1. So delta H is equal to delta U plus RT. So here this delta H value is equal to the delta U, and you have to add something, then it is equal. So here delta H is greater than delta U. Got it? So these kinds of things are there. So this is more than enough, children, and remaining things, questions and all, we will solve in the next video. So thank you, children. Thank you for watching. Please watch the video and subscribe the channel.